We are back again, my friends. We are here now to talk about constant rate infusions, or CRIs. Your book covered these pretty in depth for you, talking about formulas and kind of exactly what a CRI is. A CRI is going to be used when medication needs to be delivered IV over a specific period of time. It can be anything from 12 hours to 24 hours to 48 hours. These are typically drugs that have a very short half-life, so they need to be given constantly in order for them to be effective. So things like fentanyl, dopamine, metoclopramide, these are all things that we can give via CRI. And a lot of times these questions may ask us to mix them into a bag of fluids, or maybe your clinic has a syringe pump, so simply all you have to do is do this initial portion of math here. So the basic formula for a CRI, without talking about adding the CRI into a bag of fluids, is going to be the dosage rate, or the number of milligrams per kilogram multiplied by the body weight in kilograms, and that will give us the milligrams to administer during a specific period of time. And again, that period of time is usually always included in your dosage rate, or your milligrams per kilogram per hour, per 24 hours, etc. Okay. Once we get that milligram during a specific period of time, we will take those milligrams over that period of time and divide it by the concentration of the drug, so which is typically going to be injectable, and that is going to be our milliliters over a specific period of time. So if we go on, we're continuing to work through our homework here. If we have number 40, which says that we are in charge of calculating the CRI for a patient that has just undergone a hind limb amputation. So they're giving us a little bit of extra information there than what we really need, sometimes just to cloud your judgment to get you a little confused. But let's continue reading. Your doctor wants this patient to get 0.8 milligrams per kilogram of morphine over 24 hours. So there is definitely some information there that we need to be aware of. Or this is our dosage rate. So we can see our dosage rate, which is again always typically expressed as milligrams per kilogram, or even grams per kilogram, milligrams per pound, etc. So we are going to go ahead and highlight that so it stands out for us. And then since it is a CRI, it is typically over a set period of time, which we now see is 24 hours. We continue to read. We see that our patient weighs 60 pounds and that the available concentration of morphine is 25 milligrams per milliliter. Our doctor reminds you that this patient will also receive 500 milliliters of fluid during that time, and you only have 1 liter bags of fluid to choose from. So the patient weight is important, so 60 pounds. It is also important to know the concentration of the morphine, because again, if we look at our formula, we do need to know the concentration of that drug. So let's go ahead and highlight that as well. So that 25 milligrams per milliliter. And we continue to read, and we see that this patient is going to be receiving 500 milliliters of fluid during that time. So 500 milliliters of fluid during that same 24-hour time period. But it's also super important that we note that we only have 1 liter bags. Okay, so all of that information is so important as we kind of start to work through this CRI. And so this CRI specifically has a couple of different sections here that we need to answer, so it kind of breaks it up for us a little bit into smaller components. So the first thing we need to figure out is, what is the dose of morphine this pet will get? It doesn't specify milligrams or milliliters, but if we go on down to see B, and it says how many milliliters would that be, so we obviously know that A is going to be asking for the milligram amount of medication during that 24-hour period. So let's come back over here to our handy dandy scrap paper, because we should always be doing our best to show our work. Not only does that show our instructors that we know what's going on, it allows us to identify mistakes and we can review those, okay? So starting with A, again, what is the dose of morphine that this pet will get? Let's look at the information that we have, okay? So the question tells us that our pet weighs 60 pounds. And just remember that the number sign can be used to identify pounds, and that the dose or the dosage rate of the medication is going to be 0.8 milligrams per kilogram per day or per 24 hours. So sometimes you'll see the dosage rate just written completely out like this. So 0.8 milligrams per kilogram per 24 hours. Maybe it says per day. Maybe it says per 12 hours or half day. Again, that's all just to add a little bit of confusion in there to make sure all your units match. So we can see here that this formula requires our patient's weight to be in kilograms, and the patient weight we're given here is in pounds. So let's go ahead and let's do our first step of all dosage calculations, which is going to be to convert pounds to kilograms. So we're going to set up our equation, 60 pounds. We're going to put our pounds on the bottom because we want rid of those, our kilograms on the top because that is our goal unit. So for every 1 kilogram, which is the larger unit, we're going to have 2.2 pounds. Our pounds will cancel out. We will multiply straight across, giving us 60 divided by 2.2 is going to equal our body weight in kilograms. So take your calculators out. Let's do that math. Meaning that this pet is going to weigh 27.27 kilograms. This is one pet. I would say let's go ahead and let's just round up. So 27.3 kilograms for this pet. Okay. And again, if you're a visual person, we can go ahead and highlight that so it doesn't get lost sometimes in our sea of mathematical calculations here. So now that our units match, we can go ahead and solve for A, which is what is the dose of morphine that this pet will get. We will start with our body weight, so that 27.3 kilograms. And we're simply going to multiply it by the dosage rate, so by 0.8 milligrams per kilogram per 24 hours. So our kilograms will cancel out because they're on each side of our mathematical calculation there. And then multiplying just straight across, so 27.3 multiplied by 0.8 is going to give us a dosage rate of, let's see, 21.84 milligrams. Okay, let me make sure my math is right. Yep, 21.84 milligrams. And again, so let's not forget our period of time there, so make sure you put per 24 hours. So that is the answer to A. So let's highlight that one blue. So there is our answer to A. B says how many mLs would that be in that same 24-hour time period? So in order to calculate mLs, we can see up here in our formula, it's our milligrams per period of time divided by the concentration of the drug, and that gives us our mLs for that period of time. So all we have to do is take this information here that we just calculated. So 21.84 milligrams. And we're going to, if you want to set it up like an equation, that is absolutely okay. We can put our milligrams on the bottom because that's what we want to get rid of, our mLs on the top. And if we look back to our work here, we can see that morphine is a 25 milligram per milliliter concentration. So for every 1 milliliter, we're going to have 25 milligrams of morphine. We're going to multiply straight across. Our units cancel out because milligrams is on the bottom here, but on the top over here. So that's going to give us 21.84 divided by 25, and that's going to equal mLs. So again, get those calculators out. Divide that 21.84 divided by 25, and that should give us 0.87 mLs per 24 hours. And again, I apologize for my handwriting. It's a little crazy. And of course, my crazy slip-ups sometimes. I say crazy things every now and then. So that would be our answer to B. So again, we can highlight that blue since that is an actual answer we will need to put on our homework. And we can come over here and we can start filling this out. So we know that A is going to be that 21.84 milligrams per 24 hours. And again, do not forget those units, because without those units, that 21.84 milligrams could be anything, or that 21.84 could be anything. 21.84 apples, 21.84 syringes. So again, without these units, it kind of leaves us in the dark. So for B, it is going to be 0.87 ml per 24 hours. So again, make sure you got those units, because otherwise that 0.87 could be just about anything. So the next question tells us, how much morphine would we add to the IV fluids? So the automatic answer we would want to think is, let's just go ahead and let's add that 0.87, but that's not always necessarily true. Because if we continue to read our question or go back and reference our question, the doctor tells us that during that same 24-hour time period, the animal is going to receive 500 mLs of fluid. So for that 500 mLs of fluid, you would need that 0.87 mLs of morphine in that quantity of fluid. But we go on to see that we don't have the 500 milliliter bags in our clinic. All we have is 1 liter bags. So we got to kind of troubleshoot a little bit. How do we make sure that the animal gets this rate of morphine coming out of this bag? So it's honestly pretty easy. So what you're going to do is you're going to convert 1 liter to milliliters. And so simple conversion, you're going to set up your equation, liters on the bottom, milliliters on the top, because that's our goal unit. For every 1 liter, the larger unit, there is 1,000 milliliters. We're going to multiply straight across. Units are going to cancel out, so 1 liter is equal to 1,000 milliliters. So if we know, again, that pet is going to get 500 milliliters of fluid during that time, all we have to see is how long this 100 milliliters of fluid is going to last. So if we divide it by that 500 mLs per day, we're going to know that this bag of fluids is going to last 2 days. Okay, 2 days. So that's very, very important. So that bag of fluids, that 1 liter bag of fluids, in theory, is going to last this pet 2 days. So with that information, we can come back over here, and we know that for every 24 hours, that is 1 day. So every 1 day, this pet is going to get this 0.87 milliliters of morphine. And this last question this question C is asking us how many mils of morphine do we add to that bag of fluids. So literally all we do for C is we're going to take that 0.87 mLs per 24 hours. And again, we're kind of skipping a step here because we know 24 hours is 1 day, and we're going to multiply that by 2 days. So those guys would cancel out because, again, that would be 1 day, that would be a day. So 0.87 multiplied by 2, and that's going to give us 1.74 mLs of morphine are going to go into that 1 liter bag of fluids, okay? So the answer to C would be 1.74 mLs. 1.74 mLs. So let's come over here. So we're going to, again, so pretty much how much morphine are we going to add to the IV fluids? It's going to be 1.74 mLs. So how many mLs of IV fluid are you adding the morphine to? So you have to remember that when you're doing a constant rate infusion, you don't just add the 1.74 to an entire 1,000 liter bag. For whatever you put in, you must take out the same amount. So what D is asking you is, after you take out the 1.74 that you're about to put in, what quantity of fluids are you adding the morphine to? So literally, again, what you put in of a medication, you must take out. Because the way that we solved this problem was for 1,000 mLs total, including the amount of medication that we're using. So for D, it's going to be super, super easy, just basic subtraction. We're going to take that 1,000 milliliter bag that we calculated up here, And we're just simply going to subtract the 1.74 mLs of morphine that we are adding to the bag. So if you again pull out that handy dandy calculator, you're going to do a little bit of that math. 1,000 minus 1.74 means that we are adding that 1.74 mLs of fluid to 998.26 mLs of fluid. And so that there is the answer to D. So I almost put 9.98. So 998.26 mLs. Awesome. So that one was really nice. I'm trying to make sure it's close enough here for you guys to see. So that one is really nice because, again, it does kind of walk us through step by step how to do that basic CRI. So that's kind of a really nice fundamental one for us to start with. And, again, just using that formula in the book. And then we did add that little bit of an extra step there at the end by figuring out when we add it to fluids, how long those fluids are actually going to last that PET, and then going from there. So instead of saying that the fluids are going to last, 500 mLs per day, it may be listed as a fluid rate in mils per hour. So if we go on to this next question, number 41, which is for a metoclopramide CRI, the question says that we have a 7-kilogram dog that has fluids running at 15 mils per hour. You have been asked to make a metoclopramide CRI at a dose of 1 mg per kg per day. If metoclopramide comes in a 5 milligram per milliliter concentration, how many milliliters do you add to a liter of fluids that will continue to run at 15 mils per hour? So let's highlight that important information, okay? So the patient's weight, obviously very important for us. The fluid rate is very important for us because we need to know how long those fluids are going to how long those fluids are going to last when we add that medication into that bag of fluids. Right here we have the dosage rate of metoclopramide, which is 1 mg per kg per day. And then here we have the concentration of 5 milligrams per milliliter. And then here we have the information that we're adding it to a liter of fluids. Okay, so that is all the information that we need. This continue to run at 15 mils per hour. This is kind of redundant. Again, just trying to confuse you a little bit, but it's just kind of there. So first things first, we need to calculate our dose per day of that metoclopramide. Sorry about that. So let's calculate that dose per day of metoclopramide. So we know that patient's weight, 7 kilograms right there. And we're going to multiply it by our dosage rate, which is 1 milligram per kilogram per day. Our kilograms will cancel out because they're on both sides of our equation, giving us 7 milligrams per day of metoclopramide. So there is the first portion of our CRI calculation. Again, we're just highlighting it so it doesn't get lost. So the next portion says metoclopramide comes in a 5 milligram per milliliter concentration. How many mLs do you add to a liter of fluids that will continue to run at 15 mils per hour? So we have two options here. We can go ahead and convert this into milliliters per day, or we can wait until the end after we figure out how long our fluids are going to last and calculate it after we figure out how many milligrams total for that bag. So, but in order to keep it simple, let's continue to follow our formula, which says we should go ahead and convert this milligrams per day into milliliters per day. So let's take that information, 7 milligrams per day, and just like our formula said, we need to divide by our concentration of our drug, which our question says is 5 milligrams per milliliter. Milligrams will cancel out on both sides. So 7 divided by 5 is going to be 1.4 mLs per day. Okay, so that is the next portion of our equation, right? So that is the equation in our book that we know that we are so far on the right track. So we have our dose per day in milliliters. So now we need to know how long that liter of fluids is going to last if we run that liter of fluids at 15 milliliters per hour. So if you want, you can go ahead and convert out 1 liter to milliliters, but we know, kind of one of those remember things in those archives of our brain, that 1 liter is 1,000 milliliters. So if we have 1,000 milliliters of fluid and we're running at 15 mils per hour, so for every 1 hour we're using 15 milliliters, we simply have to divide. Okay, so we're going to divide by 15 mils per hour. So if you are a linear person, you can set it up like that. But if you prefer the equation format, we can simply set it up like this. 1,000 mLs, and we're going to multiply. So what we want is always going to go on the top, and then what we want to get rid of on the bottom. So for every 1 hour, it's going to be 15 milliliters. You'll multiply straight across. Milliliters would cancel out, giving you 1,000 divided by 15. And that'll give you your hours. So both options are absolutely correct, and you absolutely do whichever one you are more comfortable with. So 1,000 divided by 15 is going to be 66.66666, repeating. So in that case, let's go ahead and let's round up to 66.67 hours. Okay. So at this point, you're like, oh, well, can I just go ahead and multiply 1.4 mLs per day by 66.7 hours? And that is in one instance where I'm going to say absolutely not. So instead of highlighting this one yellow, let's make it a different color so we know that, hey, there's another step that we have to do here. Because we always, always, always need to make sure our units match. So there are 2 different ways we can do this. We can convert this into milliliters per hour, or we can convert this into days. Either way is absolutely fine. It's just whatever makes you happiest on the inside. I personally, since everything else has always already been per day, let's go ahead and turn 66.67 hours into days. So to do that, we're simply going to come down here, 66.67 hours. And again, we can set it up as our equation. We want to get rid of hours on the bottom. What we're looking for is days on the top. A day is longer than an hour, so for every 1 day, we're going to have 24 hours. Those hours would cancel out, giving us 66.67 divided by 24, and that'll give us our days. So 66.67 divided by 24 is going to be 2.7, we'll say 78, we'll round up days. So that is how long that bag of fluids is going to last. So now that we have everything matching, so we have 1.4 mLs per day, and we know that the bag of fluids, that 1 liter bag of fluids, is going to last 2.78 days. All we have to do now is multiply. So we're going to take that 1.4 mLs per day, and we're going to multiply it by the 2.78 days. Your days will cancel out, meaning that 2.78 multiplied by 1.4 means that we will add 3.89 mLs into that bag of fluid. Okay, so that there would be our final answer, which is 3.89 mLs into that bag of fluids. Okay, friends, let's titrate. So there are some instances where you guys may run into what we call a titratable CRI, or the example that we have in our homework is going to be example number 44. 44 asks us, you are asked to make a dopamine 40 milligram per milliliter CRI for a 52 kilogram dog. For ease of dosing, we need to make the CRI so that 1 ml per hour is equal to 1 microgram per kilogram per minute. You will be making the CRI in 250 mLs of sodium chloride. How many milligrams of dopamine will you add to the 250 ml bag of sodium chloride? So let's see here. So we're going to start this just like we would any basic CRI. by calculating our dose using our dosage rate and our provided patient weight. So our provided patient weight is going to be 52 kilograms, where our dose or dosage rate for this animal is 1 microgram per kilogram per minute. We know that our kilograms are going to cancel out, giving us 52 micrograms per minute. Okay. So when we look again back at our question here, it does say that it needs to equal 1 ml per hour, and we currently have it in a dosing range of micrograms per minute. So we need to make sure that we make our units match. So let's highlight this guy right here. So blue is our color. That means it needs a little bit more work. Let's highlight this blue so we know that there's an extra step that we need to do here to make sure our units match with our 1 ml per hour. So first thing we need to do is figure out how many minutes are in 1 hour. Okay? So we come over here and we need to take our 52 micrograms per minute, and we're going to multiply it by how many minutes are in an hour. And that's just one of the things, again, that should be common knowledge. So we're going to multiply that by 60 minutes per hour. Our minutes would cancel out. So 52 times 60. Give you a second to get those calculators out. 52 times 60 is going to be 3,120 micrograms per hour. Okay, so let's highlight that yellow because we at least have our units matching now. So now that we know for every 1 hour of fluids, that animal should be receiving 3,120 micrograms of this dopamine. So we can keep going now, and we see that the CRI is going to be made in that 250 ml bag of sodium chloride, and we need to know how many milligrams we're going to put in there. So just like we've done before, we need to figure out how long that bag of sodium chloride is going to last this patient. So if we have 250 mLs and we're doing that bag of fluids at 1 ml per hour, we can set it up as a division problem and divide by 1 ml per hour, giving us that this bag is going to last us 250 hours, which kind of makes sense, right? That's kind of another one of those common sense things. And if you can do it in your head, that's absolutely okay. But again, if you're a visual person like me, I even like to do those kind of simple steps out on paper just so I know that I've not forgotten any steps. So with that in mind, we need to come up here, and if we know that we're getting 3,120 micrograms per hour and our bag of fluids lasts 250 hours, we just have to do a little bit of simple math here. So we're going to take our 3,120 micrograms per hour, and we're going to multiply that by our 250 hours. Our hours would cancel out, giving us 3,120 multiplied by 250 is going to be 780,000 micrograms in that amount of fluid. But again, our question is asking us for the total in milligrams. So since our answer right here, which will be the total in the bag, is not in milligrams, we need to highlight it blue because there's one more step that we need to do to make sure we have the right answer. So let's come down here and let's convert this answer in micrograms to milligrams. So let's take our 780,000. My goodness, took a couple tries there. And we are going to multiply that and set up our equation. We want milligrams on the top, micrograms on the bottom because we are getting rid of it. Excuse me, I'm having trouble here on the bottom. So we know that milligrams is the bigger unit. So for every 1 milligram, we're going to have 1,000 micrograms. Our microgram units would cancel out. Multiplying straight across, we would have that 780,000 divided by 1,000. And that is going to give us 780 milligrams into that bag of fluids. So that would be our final answer. So that is our titratable CRI. So even if you look at these questions and maybe you get a little intimidated, maybe you get a little confused, you're a little worried, you don't really know what the next step is, always go back to the basics. At least start with what you know, which is we know we always need to take our weight in kilograms and multiply it by our dosage rate to get a dose in milligrams, okay? And there are some instances, like if it was a basic CRI, maybe we would go ahead and get our dose in milliliters. But again, this question is asking specifically for a dose in milligrams. So we just have to keep going from this point. So since our units, so micrograms per minute, didn't match our 1 ml per hour, we need to make sure that we know how many micrograms are going to be in 1 hour of time. So if there are 60 minutes in 1 hour, so that is why we multiplied our 52 micrograms by our 60 minutes in 1 hour to give us the 3,120 micrograms per hour. So with that information, we need to know how long our bag of fluids lasts. So this could have been a 500 milliliter bag, a 1,000 milliliter bag. But in this instance, we did do the smaller bags, the 250 milliliter. And we knew that our fluid rate was 1 ml per hour because it was supposed to equal our 52 micrograms per minute. So with that information, we know that that bag of fluids would last 250 hours. We simply multiplied our previous two answers together. So that way we knew that in that bag of fluids, we needed 780,000 micrograms. And then at that point, we just need to convert our final answer into what the question is asking for, which is milligrams. And here we just did that simple conversion here, giving us 780 milligrams into that bag of fluid. And if you wanted to be super awesome, you could go on and calculate that in milliliters. But again, that is not what question number 44 is asking for. And again, if you guys have questions, please let me know. Reach out directly, and we will be more than happy to work through a few more of these problems with you. Thanks. Bye-bye.